everyone. So we are group number 7. Our project is image to image translation using CGAN. My name is Sridhar Santosh Satav and my teammate is Jaya Garbhag. In this project we implement from first slide introduction. Our project is an implementation of Pix2Pix paper. Pix2Pix is a general purpose image to image translation model. This means the same model can be converted can convert map to satellite photos, edges to shoes, label to facets, etc. Then deeply understanding the paper, we selected one important task labeled to facet. Training our models from 200 pouch took about 8 to 9 hours on Colab GPU. So from next slide, motivation. Our aim is to understand GAN properly, especially how a unit generator and a patch GAN discriminator work together. Originally, Pix2Pix is means it's in 2016 was research level work at TRL 23. Our project reproduces, validates and studies the original architecture. So our TRL is around 4 to 5. TRL means normally technology read line levels. So then literature. In literature, it is means summary of the paper. The title of paper is image to image translation with conditional adversarial network by Islo at 2016. The key idea is that instead of designing a specific loss function for every image translation task, we use single CGAN framework that learn directly from data. Important contribution. A single architecture works across many tasks. The generator uses conditional input instead of noise. Then patch GAN discriminator work on small 70 into 70 patches, faster and better texture details. And then this objective of our project is to build the unit generator and patch GAN discriminator from scratch. Then implement the combined loss, CGAN loss plus L1 loss. Then train for 200 pouch on the CMP facades dataset exactly like the paper. Then generate result and compare them the original paper performing. Next slide. Methodologically, we use the CM facade dataset. Each image has corresponding label map, identifying doors, windows and wall, etc. So dataset size is around 400 training inputs and 106 test images. Pre-processing following the Pix2Pix pipeline. Resize is 286 into 286, random crops to 256 into 256 and random horizontal flip. That's all. This is Epoch and 200 platform global. Training configuration. We train a Google Colab using an NVIDIA T4 GPU. Optimizer is DAM with LR is equal to the learning rate is equal to 0.002 and loss generator loss is equal to GAN loss plus 100 into L1 loss. So batch size is 1 as recommended and total training time 8 hours 32 minutes for 200 pouch. Then model architecture visual. Normally this slide represents the training architecture and workflow of our Pix2Pix pipeline. Input generator, output, discriminator, loss computation, and back propagation. This diagram shows that. And then loss curves. The graph shows the loss curves. The orange curve is the generator loss. It decreases steadily, meaning the generator improves. The blue curves is the discriminator loss. It stabilizes around 0.5. The discriminator around 0.5 means the GAN is balanced. It is not too strong, too weak. This indicates stable GAN training. This all are generator graphs, and this slide shows about output produced by our training generator. We can see how the model convert label mapping into realistic building packets, and these are our all inputs and ground truth that we are outputs. That's what. Then future work, its conclusion. For future work, we plan to try our pix-to-pix dataset like map, satellite images, implement the FCN score metric used in the original paper for more accurate benchmarking. Conclusion, we successfully implemented and trained pix-to-pix from scratch. We learned not just the architecture but also important training technique like learning rate decay and proper processing. Then last slide, reference. These are the research papers and tutorial we refer to, including our ISLA CMP Facket dataset paper and TensorFlow pix-to-pix guide. Thank you everyone for listening. We will be happy to answer your any questions.